Good afternoon, ladies and gentlemen. Welcome back. Today we're going to be looking at Chapter 10.2 out of your book, and this one concentrates on representing three-dimensional figures on a piece of paper. Personally, I'll admit I am not good at drawing. That's one regret that I have from high school and college. I did not take more art classes. I only took one of them, and drawings that I make are not that good. So we're going to show a few ways here today of how to represent a three-dimensional shape and draw things pretty consistently, pretty consistently here. So, first type of drawing that we're going to look at is called an orthographic drawing. An orthographic drawing shows 6 different views of an object, so top, bottom, back, front, left, and right. Looking at that pyramid there, notice that the base is a rectangle, so we'd say that the bottom view is a rectangle. We'd only see that if we looked at the bottom. Front and back triangles are wider. They look like isosceles triangles. They're wider. The left and right might be equilateral triangles. They're a little closer to being equal to each other. And then from the top view, we'd end up seeing all of the points meeting each other, and overall we'd see a rectangle. Orthographic drawings are used pretty frequently when in advertising. For example, if you're trying to sell fireplaces, you might see a front view, side view, and top view of a fireplace to make sure that it's going to fit inside of your home. Right on the right side here we have an isometric view. This is not what we're talking about right now, so we'll ignore that view. But these other ones, here's an orthographic front view, here's an orthographic side view, and an orthographic top view. We are missing a few views. This side view, this right side view should have a left side view, but we can assume that we can just flip it and it looks just fine. The back and bottom views are probably not shown in this advertisement just because they're not very interesting. The back view is going to be the exact same dimensions as front view, but it's the back of a stove. No one really cares about that. Same thing with the bottom of a stove. I don't really care what it looks like on the bottom. I'm more concerned about the top, and that gives us the exact same dimensions. If we have a shape like this one right here and we want to draw the different views, go ahead and do this with me on a scratch sheet of paper. We need the top, the bottom, we need the left-hand view, we need the right-hand view, and then we're also going to have the front and back view. Alright, I'm going to start with the front view here because it's so close to what we have going on. Shoot. Front, back. Just one moment here. Left, right, top, and bottom. Alright. So front view. I see that it is 2 tall, 3 wide, and 3 tall on the right side. So I'm going to go ahead and draw that with boxes. Here we go. 1, 2 tall on the left side. It is 3 tall going on the width. It is also 3 tall going with this height here. We have the front view of this thing. Do notice that this one piece right here is closer to you than the others. I'm going to represent that by shading in a little bit this front piece. I'm going to just add on a few more cubes up front here just to represent that it is a little closer to us than the others. Back view is going to be very similar, except we just need to flip it around. So I can go ahead and draw that in here. Flip it all the way around. Here we go. And that'll look something like that. Left-hand view or right-hand. Let's start with right-hand view. Right-hand view is going to be this portion right here on this right-hand side. Looks like it's an L. It's shaped something like that. Goes 3 down and then 1 over to the left. Left-hand view is going to be the exact flip of that. So it's going to be pretty similar. Only big difference here, though, is that 2 of these pieces are way closer than the other pieces. So I'm going to go ahead and highlight, just like the front view, I'm going to go ahead and highlight a few of the pieces so that they appear to be a little closer than the others. Top and bottom views now. Top and bottom views. I'll see this side. I'm going to put this in red. I'm going to see this side, this side, this side, and this side. It looks like it goes 3 over, 1 down. So I'm going to go ahead and draw that right here. 3 over, 1 down. The view is going to look something like that. Do notice that this one here is a little closer. In fact, it's pretty significantly closer than some of the others. I'm going to shade this one very heavily. And then this one's pretty close to us, so I'm going to shade that moderately just to show that it's a little closer to us. All right. Bottom view is just going to be a flip over the x-axis for this last one. It'll be 3 over, but then 1 upwards. All right, and that is our orthographic drawing of this 3-dimensional shape. Top, bottom, left, right, front, and back. Isometric drawings are my absolute favorite drawings in the whole wide world because they can incorporate the best game in the whole wide world, connect the dots. An isometric drawing is a way to show 3 sides of a figure from a corner view. So you're going to see this from a corner. You're going to need isometric paper to draw these. If you need some, go ahead and just Google isometric paper. This will pop right up. You could print out a copy, or you can go ahead and make your own just by making rows of dots that are jittered a little bit. So row of dots, another row of dots right in the middle. It kind of looks like the American flag with the stars. Isometric drawings were used pretty popularly back in the early 90s, late 80s in video games. Back then, we didn't have good technology to show objects that were closer to us or farther away, so we didn't have a good perspective. If you look down a street, for example, notice that the road farther away from you looks smaller. Things far away from you look smaller. We didn't have good technology to do that. So back in the day, we had these things called sprites. Little computer programming term for an area that you're going to color in with some space. So like Mario back in the day was a sprite that was just moving around. These little 3-dimensional sprites, they're all the same size of cube, and each cube is decorated slightly differently. Each of these floor tiles are identical in shape and size, and then a few of them have a seat on it, for example, or maybe they're a wall. One of the cubes is a wall, or a set of trays, or some mustard, or something like that. To make these isometric drawings, follow along with me here. In order to make a cube, we're going to go and connect 6 of these dots together in order to form a hexagon. All right, so that's going to be our first step, form a hexagon. When you have the hexagon formed, you're going to drop a line straight downwards from the center and then up to the top right and over to the top left. That's going to give us a full cube, a nice cube effect. This isometric paper happens to be called 120-degree isometric paper. Why is that, Mr. Reece? Why is it called 120-degree isometric paper? Well, if you think about a full circle is 360, split that into 3 pieces, 360 over 3, going to be 120 degrees. Seems a little counterintuitive at first, but each of those 90-degree angles in our drawing is going to be represented by a 120-degree angle in our drawing. So a 90-degree angle in real life is going to look like a 120-degree angle, and that's just some perspective issues that are happening there. If I want to draw this object, I'm going to start drawing cubes that are closer to me and then ones that are farther away. So I'm going to start with ones that are closer, like this one up front. I'm going to draw this one, connecting a hexagon at first, like I said last time. Connect a hexagon at first. So we have our first cube. The next thing I want you to notice here, and I'll switch over to some orange, is that this line that we've already drawn fades into the next line. Similarly, this line fades into the next line. This line fades into the next line. Each of our lines here, this one's going to fade in to the next one. This one fades into the next one. This one fades into the next one. If you can see which lines fade into each other, that'll help you determine a little better which ones you should connect to make the next cube. We have 2 of our cubes down right now, just because I faded those lines down and connected some dots. Notice this pale cube on the side here is the next closest one to us. I'm going to go ahead and draw that one by fading this line up top into the right side. Similarly, notice that these two share a side here. I'm going to make those share a side. Well, maybe yellow shows up a little better. Excellent. I'm going to make those share a side. So, in my drawing, these two share this side. This edge also fades into this edge. After we have that drawn, this edge drawn, it goes downwards and to the left. So I'm going to also need to go downwards to the left. There's our front face. This face right here is this face right here. We can go and visualize the remainder of it by drawing in some extra pieces, like so. There's another one of our cubes. Last few portions here, if we draw a straight line straight upwards, this place where they connect goes up 2 more. So we can go ahead and do that as well. This place where they connect goes up 2 more pieces. We can go and place some more, connect the dots. And we'll get another couple of cubes stacked up top. All that we're missing now is a single piece, this dark piece on the back side here. We need this last dark piece on the back side, and it's going to appear right inside there. Which dots do you connect exactly? Well, notice that this one runs into this one. So that means that this piece needs to run into this piece. From there, it goes backwards and downwards, so I'm similarly going to go downwards and backwards to draw that last portion of this shape. Like I said at the beginning of this lecture, I'm not a very good drawer, so I'm always really happy to do these isometric drawings because it's hard to mess up when you just start drawing hexagons, unless you're bad at drawing straight lines, in which case use a ruler. You'll be fine. If you want some extra practice with that, try drawing this in the other direction where it's facing off to the right. Give that a shot, or from the back, from the front. You can get multiple views of this shape. Last type of drawing we're going to look at is perspective drawing. It's a drawing where lines seem to fade off into a vanishing point. All right, that's off on something called a horizon. 1 point perspective has a face that's facing you. Let's go ahead and write that down. 1 point perspective, a face is closest. And with 2 point perspective, it's going to be an edge is closest. What I mean by that, this edge right here is closer than anything else in this diagram. Similarly, this face right here is closer than anything in the diagram. So 1 point perspective, a face is closest to you, 2 point, an edge is closest to you. We won't look at 3 point perspective in this class, but it does exist, and that's where a vertex is closest to you. Now, if we want to go ahead and draw this, I'm going to go ahead and pull up Geogebra because it's easiest to draw in Geogebra. If I want to make a cube, let's say, I want to make a 1 point perspective cube. I'm going to go ahead and add some text here. 1 point perspective cube. That's what we're drawing first. Well, I can go ahead and make my horizon. I'm going to go ahead and say that this point A here is going to be my vanishing point. All right, so point A there, that's going to be my vanishing point. I'm going to start by drawing a simple cube. All right, so need a regular polygon, 1, 2, 4-sided polygon. Here's my cube. I want to make this appear to be fading off into the distance. So next up, I'm going to go ahead with a ruler, connect that cube, connect each of the points of the cube off to the vanishing point. It is usually nice to, let's see here, 1 and 2. It is sometimes nice to make these into dotted lines as you're drawing them. So we select several of them. Let's see here if I can get this to be a dotted line, thin dotted line. Here we go. These I sometimes refer to as ghosted lines. They're lines that seem to be fading off into the distance. If I take my cube now, I can see that there are several ways that I can draw my ghosted lines. Yeah. Next up, I need to make another one of these squares that appears to be fading off into the distance. So I'm going to see this point F here. I'm going to choose another point on its ghosted line. And then I'm going to drop a line segment straight downwards so that it shows up on the next ghosted line. Like that. Alright. What that's done for us now, we have a point F, its representation's back on G, a point C, its representation's back on H. If we go ahead and fill in some lines here, fill in these lines, it gives us the appearance that this object is fading off into space a little bit. Alright? For my next piece here, I see that C goes off to the right to D, so I'm going to go ahead and make H go off directly off to the right to that point, and I'll place some connect the dots. We have another portion of our graph. The last couple pieces of our graph are going to need to be dotted lines, simply because D going up to E, we're not going to see this I to J segment. So I'm going to go ahead and make this a dotted line because it's in the background and we don't technically see this dotted line. Similarly, if I connect G and J together, just like F and E are connected together, I'm going to go ahead and make that one a dotted line as well for the pure purpose of it being behind the rest of the faces. Alright, so now if I move my object here a little bit, we currently have a three-dimensional cube. Looks like a three-dimensional cube. We can rotate that around a little bit. Gives us a good perspective view of this thing. We can move it off to the right, to the left, bottom, top, etc. And it makes it look like the cube's fading off into the distance where all parallel lines are all meeting at a single place. I might go ahead and similarly hide these dotted lines. Here we go. Now we have a purely wonderful cube that seems to be fading off into the distance. We can zoom out to make it way taller, make it way shorter, etc. Let's go and clear that. Now with two-point perspective, we're going to still have a horizon line, just like last time. It's going to make the line go all the way through. Here we go. Here we go. Awesome. This time I'm going to keep both of my points because I am doing two-point perspective. One's fading off into the distance, the other's fading off into the distance, etc. If I want to make a block letter C, let's say, so this is two-point perspective, block letter L. I want to make a block letter L. Here's what I'm going to do. I'm going to start at an edge. I want a single edge for my L. So that's going to involve just drawing a line straight up and down. Alright, line straight up and down. That's going to be one of our edges. I'm going to go and draw some ghosted lines that's going to connect each of these vertices off to the vanishing points. And I'm going to take each of those ghosted lines and make them into dotted lines. 1, 2, 3, 4. Make them in the dotted line so we don't see them too much. There we go. Now I want to draw one of the faces. I'm going to draw the right face of my L, and I'm going to make my L fade off in the distance to the left and to the right a little bit. This is a pretty simple matter right now. What we're going to do here is just take D, go up a little ways, go straight up, and then back off to the right. Alright, that does give us a right side of our perspective L. That's one of our faces. Two parallel lines appear to be meeting at this vanishing point off in the distance. I could easily move this vanishing point and make the L bigger or smaller if I choose to. I can go ahead and draw the next face. It's going to be a little different because an L doesn't go up all the way as it gets out here. Instead, L is going to go up about maybe a third, maybe a fourth of the way up before it stops. After that, I need another vanishing line. Alright, another one of these ghosted lines. I'm going to go and make one of these ghosted lines dotted because ghosted lines are always dotted. Here we go. In this way, I can go ahead and place some more connect the dots here. Drop it down, drop it upwards. Make it as perfect as possible. And then drop this last point, J over to C. We have what's almost a perfect block L right now that's completely movable. I can change some of my vanishing points here, although I probably don't want to do that one too much. This one should be just fine. Here we go. I am missing the top portion of my L. I will need another vanishing line because it's going off to the right. I need to make it go off to the right side. I'm going to make that one dotted as well because it's a ghosted line. And then I'm going to drop this segment off to the right a little bit. Get another ghosted line inside here. Make this line dotted as well. Hopefully you're following along with me on the drawings. And then I'm going to make this last line, K, go back into this point. There we go. Now with all of these properties, I'm going to go ahead and remove several of the points. Including point K. I'm also going to remove several of the line segments. I want to keep that one, keep that one, keep that one. It's the dotted ones that I want to remove. Well, you know what? All the dotted ones are lines. There we go. Yep. Perfect. Went ahead and removed all of those dotted lines now. And that's going to give us a very nice L shape that's kind of fading off into the distance that we could take one of our vanishing points here now, move it around and widen our L if we like, shrink our L so that it's facing in another direction. So that'd be a 2-point perspective block L shape. All right. That's what all I've got for you today. Hopefully you are a better drawer because of it. If not, we can talk a little bit. We'll keep on practicing drawing. Have a lovely day. See you next time.